This is the north pole of the earth, and we are viewing the rotation of the earth through the north pole. Half of the earth is experiencing day and half of the earth is experiencing night. The meridian which separates the day and the night, we will call this as the corneal meridian. The blue dot represents the geographic north pole of the earth. This is the center of the spinning axis of the earth, which separates the day and the night. We will compare this to the human eye and we'll assume that the blue dot represents the visual axis. Then we have the optical axis around which cyclotorsion happens, and it is similar to the earth spinning axis. And the day-night separation is the corneal meridian. So obviously now you would ask me the question that why the corneal meridians are not passing through the visual axis. Now, if you take a side view of the earth, then you would understand that the geographical axis is actually spiraling or doing a circular motion around the spinning axis. In this analogy, the visual axis is represented by the blue line, and the spinning axis around which cyclotorsion happens is represented by the optical axis. So the optical axis is the one around which the earth is rotating, and the visual axis is spiraling around that optical axis. For comparison, this is the photo which shows the center of rotation passes through the optical axis and the visual axis is spiraling around the optical axis. So going back to our view from the North Pole, you can see that the blue dot, which represents the visual axis, is spiraling around the optical axis, and we are wrongly assuming that the corneal meridians are passing through the optical axis whenever we do our cyclotorsion measurements. So in reality, we would need a measurement of the meridian along this spiraling blue dot. So how can we do this? How can we measure the corneal meridian around the spiraling visual axis? To me, this problem has only one solution, that we do not measure the cyclotorsion. We can actually mark the corneal meridian around the visual axis and avoid the measurement of cyclotorsion, and this way the accuracy would be better.